Alright, gonna do this problem, ThreeSum. Alright, so given an integer array nums, return all the triplets nums of I, nums sub j, nums sub k, such that I doesn't equal j, I doesn't equal k, j doesn't equal k, and nums I, j plus always equals to 0. Notice that the solution set must not contain duplicate triplets. Alright, example 1, nums -1, 0, 1, 2, -1, -4, -1, -1, 2, yes, because they add up to 0, the -1, 0, 1 also add up to 0. Great. Distinct triplets are -1, 0, 1, -1, -1, 2. Notice that the order of the output and this order of the triplets does not matter. Cool. Okay, yeah, so 0, 1, 2, 3, or 0, 1, 2, 3, 3, 0, 3, and 4. Yeah, 0, but it also 1, 2, and 4. 1, 2, and 4, but it's also all already covered by 0, -1, 0, 1. Okay, yeah. The only possible triplet does not sum up to 0. Okay, yeah. 0, 0, 0. Only possible triplet. Okay. So it's always going to have at least 3 numbers. Yeah. Okay, cool. Alright, so starting off, let me try to see if these are sorted. Okay, they're not necessarily sorted, but you need to preserve the order because you'll need to know the index and you'll be returning, or do you need to know the index? Interesting. So currently I'm thinking whether or not I need to sort nums and add that time complexity. I'll write through what I think might be, or at least my thought process of what the approach might be. So okay, so I think what we're gonna have to do is for each number, we're gonna have to loop through the nums, and then take that element and add up 2 other elements. If they equal to 0, push that to a solution array, and then try to avoid duplicates by incrementing and decrementing. Okay, so if we're gonna have to increment and decrement as to avoid duplicates, then I think we're gonna need to start by sorting. After sorting nums. Try to avoid duplicates by incrementing and decrementing, return the array. Okay. So to start off with, like we mentioned during the pseudocode of this, we need to sort nums, and that'll be okay because we are returning the actual element itself and not the index. Okay, so nums sort for I in range 0 len nums, if nums sub I, if I equals 0, meaning it's the first element, or nums sub I does not equal nums sub I minus 1, meaning it's not the same as the element that preceded it, then we will execute let's just say ThreeSum. We'll write a method called ThreeSum because which will take the element um, that the num sub I, and it will add up two other triplets in a two-pointer fashion, similar to how we would do two-pointer, or sorry, ThreeSum. So we'll do um, nums self dot ThreeSum, not ThreeSum, self dot TwoSum, and let's just say we need to send in the index, so I, and then we also need to give them the target. And since the target, we could either add up all three of the numbers, or I think what would make more sense is if we did target minus num sub I, because that's how much you would need to add up to in order to no, not target, because the target is 0, so it actually would be negative nums sub I, because that is what you would need to add up in order for to equal 0, which is ultimately our target. And then you need to also pass in the nums itself, and you need to pass in res. We'll call that the array of the solutions array. All right. So self.toSum. So that means we need to return res, and we also need to define toSum. And we'll do a self passing in self, and then I. Let's say the ThreeSum index. And we're going to say the target, let's just call it the target int, and then nums is going to be list of int, and then res is going to be list of ints. All right. Now what are we going to do inside this one? Okay, so for a ThreeSum index, we say left equals ThreeSum index plus 1, because we don't want it to be duplicate, and then right is going to equal len nums minus 1, so the last element, while left is less than right. Total equals nums left plus nums right. If total equals the target, then res dot add or append is the right way to say it, and you would be, let's say, nums of ThreeSum index, nums sub left, nums sub right, but this needs to be an array, so you would do this and this, so one solution. And what we'll also need to do is we'll need to make sure that we skip over duplicates, so while left is still less than right, and nums left equals nums left minus 1 or plus 1. I think, is it left? Well, nums of left equals nums left minus 1. This one equals nums left. We're going to increment left plus equals 1. And that should take care of right, or I think maybe we need to go left as well. Okay, so left for minus right, and nums right minus 1 equals nums right or maybe we'll just say, yeah, nums minus 1 equals from right minus equals 1. Yes. Okay. And that's what we'll do. But elif total is less than target, then left plus equals 1. elif total greater than target, right minus equals 1. Okay, so let's go ahead and test and see if this is correct. So we have left and we have a res. Okay, all right. So we're going to take a specific example and we're going to sort it and do something to it with our code. So we're going to run through a test case. All right. So let's see. In the case of this first test case down here, if you were to sort it, you would have -4, -1, -1, 0, 1, 2. Okay. Right, 6 numbers. Yes, okay. So starting from the fourth one, you would go the left. Let's see if there's a better place that maybe we can extend this window just a tiny bit. Extend this window just a tiny bit. Okay. So if the starting element is -4, so left. So the first one is I equals 0, so it's going to definitely go. So self.ThreeSum is going to be called with self.ThreeSum is going to be called with 0. Negative num sub I, which is going to be 4, and it's going to be called with nums and then the result. Nums and then result, yeah. Which are, yeah, nums is nums and res is going to be an empty array at this point. So, then left is going to be, left, right are going to be ThreeSum index plus 1, which would be 1, and right is going to be, in this case, 5. So total equals nums left plus nums right. So that would be -4 or -1 plus 2, which is -1. And is it equal to the target? It is not, because our target is going to be, target is 4. Oh, target is 4. It's 4. So does it equal the target? No, it does not. So -1, 4. So we're going to go to the left. The total is underneath the target. So go to the left, try again. -1, same result. So left is going to increase again. Left is now going to be 0. Left, right is going to be at 0, not 0, but 1, 2, 0, 1, 2, 3. So 3, 5, and that's still not going to equal. And then we're going to go all the way to the end. Well, 1 and 1 and 2, that's equal to 3, still not equal to 4, in which case we're now out of the bounds. So left and right are going to be, this is a little confusing, but essentially 4 and 5. So we have reached the end of this, and that means we're going to have to increment the next one in ThreeSum. So now self.ToSum is called with 1, and then what is the negative of that, which is 1, negative num sub I, nums res. Left, right is going to equal, at this point, we're starting on index 1, and so it's going to be 1. Yeah, it's going to be 1. Or yeah, index 2, because right now we're on index 1 for the threesum, and then we're going to be at index 5. 5 still. Yeah. Yeah. Okay. Now do these add up? So -1, -1, and so what are the target is 1, but in this case, total equals nums left plus nums right. There is one thing. Is there? It cannot. It cannot complete duplicate triplets. Okay, so -1, um, -1, -1, 2, and that should add up because right now we're in index 1 for threesum and index 2 for twosum, and then index 5 is so 2. So -2 plus 2 equals 0. So it should be. So okay, let's see what we got. So total in this case would be -1. Or no, it would be 1. Total is 1, so it equals. So there's res append, nums threesum, threesum index, which at this point should be -1, and then nums left, which should be -1, and then it should be 2, which should be one of the solutions. Yes. And in this case, after it's appended to res, while left is less than right, and nums left plus 1 equals nums left. Does it equals nums left? It does not. So it's going to keep going left plus equals 1. So it's going to try to do index 3, 0, which is 0, is 0, and index, and while left equals right, and nums right -1 equals, it doesn't equal. There's no duplicate there, so it's going to be still at index right, is index 5 is 2. So 0 and 2, and that 2 is going to be greater than 1. Hold on. And that 2 is going to be greater than 1. Well, basically we don't have to decrement right, but we don't have to increment left, so we go back to the start of the while, to rerun the while loop again. So total now equals 0 plus 2, nums left and nums right, and that's going to equal to 2. Does 2 equals 1? No, it does not. It is greater than 1, and so right is going to decrement. So index 3 is going to be 0. Index 4 is, what was it again? Maybe let's move this down here. So index 4 is 1. So -1, 0, 1. We're still on index 1 for -1, -1, 0, 1. And that should give us, now we do have a target that equals, so res should be appending another another solution. It would be -1, 0, and 1, which is actually one of the triplets. So great. And then we'll continue, and at that point that would be the last iteration, because the increase of left plus right, or left plus equals 1. Actually, I'm thinking of something where we actually missed, or I actually missed something where we actually have to increment this left plus equals 1. And do we need to decrement right? I believe we do need a decrement. Yeah, we do need a decrement. we need to increment left and right no matter what, just so we don't get into a like a execution exceeded, because otherwise the loop won't go anywhere. And then in that case, if there is still um, duplicates, then they should be caught by these lines of code here. Okay, so now that we've corrected that, res append -1, 0, 1, so our results array is going to be too long, or 2 items long. Now, on the next iteration, we're going to exit the while loop and then move on to the next item in ThreeSum. Now, in ThreeSum, we should be, we were at index 1, and now we're going to index 2. So we were at 1, and now we're at 2. But we should run afoul, or we should hit this condition. So if nums sub I doesn't equal I minus 1, which it does, so that means we're going to skip number 2, the 2 index, because it's equal to the one directly below it. So the next one is going to be 0, 1, and 2. And we could just do, well, we could finish it off. So ThreeSum index is going to be 0, is 4 or 0. The element is going to be 1 or 0, sorry. 4 or is 3, sorry. Or an element is 0. Left is going to be, I think, what is 4. Right is 4, 5. Or element is 0 is 1, and right is 5, element is 2. And yes, that should be our sorted array here. So yeah, that's where our 3, 4, 5. And these obviously don't add up, but let's go through and see if it actually doesn't. So left is less than right. Left is 4, right is 5, right? Because it's 3 index plus 1. Left is 4, right is 5. Total equals nums left, that is equal to 2, left and right, 1 and 2, which is equal to 3, which is definitely not 0. And so we're just going to skip it, and that should give us our answer of 2. And let's give it a shot. Oh, in develop syntax, what happened? Yeah, extra semicolon here. Oh, let's see. Okay, so we passed 121 test cases. Let's see what we might have made a mistake here. Why did it not catch -2, 1, and 1? So let's try this. Let's try this one. Let's see. -2, 0, output is 2, 0. So we managed to get this one. So we did get this 0, and we should have gotten -2, 1, 1. Why didn't we? So at this point, we would be. I'm going to assume this is already sorted, right? So we should be at left equals ThreeSum index. So right off the jump, let's go ahead and erase this. We should be at 0, and left was 1. Left is 1. Left is 1. Right is 4. 0, 1, 2, 3, 4. Okay. So we caught that one. Why did we not get the second solution? And that would be because so continue to execute while left is less than right. Total equals nums left plus nums right. So nums 1 plus nums right should be which should equal to, in this case, and let's just write the array out here, -2, 0, 1, 1, 2. So num sub 1 right is 4. And what happened here? The total was that. We appended it. We're on line 24. Left plus equals 1. So left is now 1. And right is now, sorry, right is technically, left is technically 2, and right is technically 3. Right is 3 because we're incrementing and decrementing from our last code, from our last successful append. While left is less than right, which it is, and left plus 1 equals nums left. It looks like there's an error here. So what should we do in this case? So we incremented both while left is less than right, and nums left plus 1 equals, maybe it should be actually -1, because if the last one is equals left, and so instead of looking at the one ahead of it, it should be the one we just used. So that would indicate left -1, and that would be okay because we incremented left automatically anyway. And this one should be right plus 1 equals nums right. And in that case, we should not have to skip this one, and then we would successfully do those two again and equals, and that should solve it. Okay, yeah. So that was the error. We just had a mistake in how we check for duplicates. And okay, so time complexity here. So you're looping through the elements once, so it's n, and then you're performing ThreeSum. So for each one, I would say you're potentially going through the list of elements n times. I would say this should be a n squared exponential time, because for every n you're potentially looping through the rest of the elements n times, so you should have n squared time complexity. And as far as space complexity, it should be constant because we are not, well, the solutions array, we're going to be storing triplets, so I would just say potentially n, because somewhere below, because you're always it really depends on how many solution triplets you find. You could find very many. It wouldn't be equal to n exactly, but just a few less than n, I would say. So yeah, so removing the coefficient, you would have linear space complexity. So accepted. Let's see if there's any way that we could. I don't know if there's any way we can do an analysis on the time complexity. Oh, this should be, yeah, n squared. Okay. All right, that concludes the solve of ThreeSum.